All students need to understand the mathematical concepts of fractions, rate, and proportion. Proportional reasoning has many practical applications and is essential for scientific and engineering practices. But as any elementary school student or teacher will tell you, these concepts can be very difficult to learn. One way to approach this instructional problem is to step back and ask how people learn concepts to begin with. For centuries, it's been recognized that people learn through interacting with the world. When computers entered educational practice, they provided limited forms of interacting with the world because the user interfaces were not yet sophisticated enough to let students interact in naturalistic ways. But now we have natural user interfaces such as Wii, Kinect, and touchscreen tablets. This range of platforms is once again allowing educational designers to build activities in which students interact with objects. Often these are virtual objects, but they elicit and shape essentially the same perceptual and action patterns, what we call sensory motor schemes, as what we find with concrete objects. But what can students learn through interacting with virtual objects? Well, students can use educational software no matter where they are, just as long as they have a computer. But then again, you don't just find teachers wherever you are. One idea is to create virtual teachers and put them into the same virtual spaces. What should these virtual teachers be able to do? We probably want a teacher to be able to speak. What else? A growing body of research supports the claim that when teachers teach, they not only speak about the content, but they also move their hands in ways that are meaningful and important, what we call gesture. And if kids are learning through interacting with objects, perhaps also the virtual teachers should be able themselves to manipulate the virtual objects and gesture about these actions. How do we do that? Animation software now enables us to create virtual characters that move their hands in ways that look quite naturalistic. Still, how might this virtual teacher know when to do what? The virtual teacher needs a virtual brain. State-of-the-art artificial intelligence is now enabling students to receive customized feedback from software as they interact with technology. And so, building this brain would enable the virtual teachers to speak, gesture, and act intelligently, working with individual students in real time, responding in ways that optimize for learning. All these innovations have created an opportunity to design an interactive human-like teacher or pedagogical agent that intelligently and responsively supports the mathematical learning of students as they engage in interactive work with a computer interface. Our virtual teacher has a name. Meet Maria.